We have the question number 10 from the first two units. It says the plates of a parallel plate capacitor have an area of 100 centimeter square each. So this parallel plate area A is equal to 100 centimeter square. So the problems will be same method repeated, but there will be certain small amount of changes. Earlier you might have millimeter square, meter square, so now it is centimeter square. So let's convert it to standard meter square. 100 centi, that is 10 to the power minus 2 meter whole square. So the area becomes 100 into 10 to the power minus 4 meter square, standard unit, and are separated by 3 millimeters. So the distance between the plates D is equal to 3 into 10 to the power minus 3 meter, millimeter, 10 to the power minus 3 meter. The capacitor is charged by connecting it to a 400 volt supply. So the voltage supplied to the capacitor is 400 volt. Okay. Calculate the electrostatic energy in the capacitor. So we need to calculate the electrostatic energy in the capacitor. The formula for that what we have is energy stored in capacitor A is equal to half CV square. So we need the capacitance. So first we need to calculate the capacitance using A and D. So capacitance C is equal to A epsilon naught divided by D. A epsilon naught divided by D. So area 100 into 10 to the power minus 4 into 8.854 into 10 to the power minus 1 whole divided by D, that is 3 into 10 to the power minus 3. So let's solve this. So we get 295.13 into 10 to the power minus 16 and plus 3, so that is 10 to the power minus 13. So minus 4, minus 1, minus 16, 10 to the power minus 3 moves upwards becomes plus, so that is minus 13. You can also write this one as 29.51 into 10 to the power minus 12 farad. So let's substitute this value here and find out the energy stored in the capacitor. So that is half 29.51 into 10 to the power minus 12 and 400 square multiplied by 400 square. Let's find it out. So we get 2.36 into 10 to the power 6. So minus 1 I already have and 10 to the power 6 I will get. So when I solve this, 2.36 into 10 to the power minus 6 joules. So this is the energy stored in the capacitor. First problem. The second one, up to here we have calculated the energy stored in the capacitor. If a dielectric of dielectric constant is introduced between the plates of the capacitor, then find the electrostatic energy stored. So here we need to say that when a dielectric constant is introduced, the capacitance changes. How it changes is C is equal to K into the earlier capacitance. So or else you can write this as A epsilon naught by d. So this can be K, that is 2.5 into this entire A epsilon naught by d is 29.51 into 10 to the power minus 12. So 29.51 into 10 to the power minus 12. So we get 73.7 into 10 to the power minus 12 farad. So the capacitance has changed. If a dielectric of dielectric constant 2.5 is introduced between the plates, so the capacitance increases. Then find the electrostatic energy stored. So let's do that. After finding out the capacitance, we need to find the electrostatic energy stored. So I call this one as E2 and this one as E1 because second time we are finding out the energy in a different case. So I call it as E2. So half Ck into V square. So this becomes half into 73.7 into 400 square. So it's 73.7 into 10 to the power minus 12. So we get this value as 5,000. Yeah, 5.9. I can write as 5.9 into 10 to the power 6 into 10 to the power minus 12. So we get it as 5.9 into 10 to the power minus 6 joules, that is E2. So we calculated the energy stored in the capacitor when a dielectric constant is introduced. The problem does not end here. They also asked and also calculate change in energy stored. So the final energy minus the initial energy, that is when we introduce the dielectric constant, the energy increases. Without dielectric constant, we have certain energy. So change in energy, that is you can call it as delta E, that is E2 minus E1. So 5.9 minus 2.36, 3.54 into 10 to the power minus 6 joules. 3.54 into 10 to the power minus 6 joules is the change in energy with respect to the two cases. It's a bit lengthy, but it's an easier one. Let's start with the next one. Yeah, let's start with the question number 11 from the first two units. It's also regarding the capacitance of parallel plate capacitor with one small difference. I will let you know what is that. It's asked in March 2019. In a circular parallel plate capacitor, so that's the difference. In a circular parallel plate capacitor, radius of each plate 5 centimeter and they are separated by distance of 2 millimeter. Okay. In earlier problems, it was in a parallel plate capacitor the area of they were asking, but here they have given the radius. Then we need to calculate the area. Then we need to proceed. So earlier it was direct. So the area of the parallel plate capacitor each of area. So here it is somewhat different. Circular they say, they gave the radius. So pi r square we can calculate the area. Okay. In circular parallel plate capacitor, radius of each plate, so r is equal to 5 centi. So I write it as minus 2 meter. And they are separated by distance, that's given directly. D is equal to 2 into 10 to the power minus 3 meter. Calculate the capacitance, so C, and energy stored when it is charged by connecting the battery of 200 volt. So capacitance and energy stored when it is charged by connecting the battery to, so the potential difference 200 volt. So let's solve this. Radius is given, capacitance is related to distance and area. So let's find out the area of the circular parallel plate. Area of circle is pi r square. So 3.14 into 25 into 10 to the power minus 4. So 3.14 multiplied by 25. So it has 78.5 into 10 to the power minus 4 meter square. So area should be meter square. So capacitance C is equal to A epsilon naught by D. A 78.5 into 10 to the power minus 4 into 8.854 into 10 to the power minus 1. Permittivity of free space epsilon naught divided by 2 into 10 to the power minus 3. So let's calculate this. 78.5 multiplied by 8.854 divided by 2. So it does 347.52. So minus 16 plus 3. So minus 13 into 10 to the power minus 13. Get? I can write it as 34.752 into 10 to the power minus 12 farad, or simply 34.752 picofarad is the capacitance of the circular parallel plate capacitor. Next we need to calculate the energy stored. So potential is given, capacitance we have, so the energy stored is E is equal to half C V square, so 1 by 2. Capacitance we got it as 34.752 into 10 to the power minus 12. This is 200 square, 4 zeros. Do like that. So on solving this, get it as 6.95 into 10 to the power 6 into 10 to the power minus 12. Finally 6.95 into 10 to the power minus 6 joules. So this is the energy stored between in the capacitor when it is connected to a voltage of 200 ohms. So as you see, collection of data plays a very important role. So collect the information whatever they have given and relate them to the value we need to be calculated. That's the only thing we need to do. Let's start with the next question.